Okay, so what we're going to talk about today, it's a relatively short lesson. We probably will not get through all of the practice, but that's okay because the practice goes a little more extended than we need to. But it's a relatively short lesson because it's very similar to yesterday, except instead of just using addition and subtraction, we're going to throw in multiplication and division. Okay, we're still only doing one-step algebra problems here. So what is the inverse operation of multiplication? And then what's the inverse operation of division? Good. So if I'm doing a multiplication problem, what is that typically going to look like in algebra? How would that physically look if I were to write out a multiplication problem? I guess my question is, do I usually see a symbol? No. So usually a multiplication problem will look something like this. 6x equals 36. How do you recognize that it's multiplication? If there is no sign, or if it's in parentheses, that means multiplication, right? What are some of the other symbols you've seen for multiplication? A dot. An X, but we don't usually see that anymore because now that we have variables, that makes it confusing. And then sometimes you might see like a star. I put stars sometimes because that's on the computer what it lets me put in Smart Notebook rather than a dot. So that's why I use stars sometimes. So if you see that, that means multiplication. But typically it's going to look like this. So how would you solve this? How would you solve this? 25. Alondra? Okay, I'm going to divide 5 on both sides. How do we write that? Zulema? Yeah, it looks like a fraction bar, right? Yeah, so we divide by 5 on both sides, and it looks like a fraction because every fraction is just what kind of math? A division problem. And if I do that over here, what do I do here? Good. What happens here? Okay, let's again think about what we mean when we say cancel out. 5 over 5 is actually what? 1. Do we need to write that 1? No. So is it just disappearing? It's becoming a 1 and we just don't need to write it, right? So what's left here? 1x or just x because we just write x. And then what does it equal? 5. Very good. X is by itself. I'm done, right? I don't have anything else to do. So now x is alone, x equals 5. Just a quick mental check. 5 times 5 is 25. Okay, we're good. All right, so that's when we're solving with multiplication. All right, what's this? Division. So if I want to cross out a division problem, what's my inverse operation? So what do I do? This is x. How would you say this? X over 4 or x divided by 4. How do I get rid of or make disappear a divided by 4? Jesse? Multiply by 1 over 4. Is that going to work? If I multiply by 1 over 4, that's going to give me 1 times x, which is 1x, and then 4 times 4, which is 16. So did that get rid of my 4? So I don't want to multiply by 1 over 4. Jesse, you're right in that I want to multiply by a fraction. But what's the fraction I want to multiply by? Where does the 4 need to be? Exactly. Perfect. So I'm multiplying by 4 over 1. Because then I'm going to long write this out. You don't ever have to do this again. But what's 4 times x? 4x. And what's 1 times 4? And then what happens to those 4s? They cancel out. They go away because they just become a 1 and we don't need to write it. Okay, do you have to write that every time? No, but that's what's happening there. So all I'm left with is x. And then over here, I multiply by 4 over 1, and that gives me what? 12 over 1, which is the same as just 12. Okay, for some reason, I don't know why, but for some reason, when people see this fraction bar, they automatically assume it's something really complicated. It's not. To cancel out division, we use multiplication. If I want to get rid of a 4 on the bottom, where does the 4 have to go? On the top. Okay? So if I had something like this, what do I need to get rid of? The 2, and Andy, you said the 5. Do I need to get rid of both of them? Yeah, I have to get rid of both of them because I want x by itself, right? Can you read this for me as a fraction? Elijah? Okay, 5x over 2, but I only want to get rid of the 5 over 2. I don't need to get rid of the x. So if I want to get rid of a 5 over 2, how would I, air quotes, get rid of that 5 over 2? Elijah? Exactly. Multiply by 2 over 5. Because if the 2's on the bottom, where does it need to go to cross it out? On the top. And if the 5's on the top, where does it need to go to cross it out? Good. What is this called, this thing? When you flip a fraction, what's it called? Starts with an R. Reciprocal, exactly. So you multiply by the reciprocal. This is the reciprocal right here. We just put a 1 there because there wasn't a number there before, but there's a 1 right here. So we're just multiplying by the reciprocal. So what happens with my 2's? They're gone. What happens with my 5's? They're gone. And what do I have left? X. Okay, what do I multiply by over here? 2 over 5, because that's what I multiply by over here. And remember, an equal sign means it's like a scale. Whatever you do to one side, you do the exact same thing over here. So 2 over 5. I put 6 over what? 1. What's 6 times 2? And what's 1 times 5? I'm lazy. I'm leaving it like that. 12 over 5. Okay? So how do you get rid of a fraction? Multiply by its reciprocal. All right? And the reciprocal is just a fancy word for saying do what? Flip it. Exactly, flip it. Which is what you do when you're dividing with fractions too. You flip it. Okay? Flip the second fraction. All right. So we're going to go through a couple of these together. You guys are going to do the second practice. I want to look at number 13. What kind of math would we do in number 13? Multiplication by what? 18 over 1. So on this side, I'm going to multiply by 18 over 1. What happens here? They go away, and I'm left with b equals, and then I would have to do negative 6 times 18. Is my answer going to be positive or negative? Negative. So it's negative 6 times 18, which is 108. Positive or negative 108? Negative 108. Perfect. Negative 108 equals b. What kind of math would I do for 18? Division. What am I dividing by? Negative 17. Negative 17. These go away. If they're both negative, my answer is positive. So my answer ends up being positive 12, I believe, right? Sorry, yeah, positive 12. All right, last but not least, let's look at 20. M over 4 equals negative 13. What am I getting rid of? 4. How am I going to get rid of it?
4.
Times 4 over 1. So on this side, I do times 4 over 1. What happens here? They cross out, so I'm left with m equals negative 52 over 1. Do I need that one? No, it's a whole number. Just leave it. So again, we see this, we look at it, it looks like a fraction. We don't freak out. Remember that to get rid of a fraction, we just multiply by its reciprocal. In this case, the reciprocal is just 4 over 1 because there isn't a number here, so you assume it's 1. All right? Okay, so how would I get rid of this one? Like the other one? So what am I going to multiply by here? 4 over 3. Why? That's the reciprocal. So 4 over 3. If I do it here, what do I do here? Same exact thing. Good. Great job, guys. Okay, what happens with the 4s? What happens with the 3s? What am I left with? equals 1 times 4 is, 2 times 3 is 6. Not for multiplication. No, multiplication's easy peasy. You don't have to put it in any type of lowest terms until you get down here. Now, this is 4 over 6. You can do it on your calculator and get a decimal. You can reduce it by what? 2. And that gives you, if you don't do it on a test or a quiz, I'm probably not going to mark you wrong. I'm not testing you guys really on reducing, but since you have calculators, it'll do it for you. So if you want to, you can. I'm not that concerned about it, but when you take a grade cam or like your midterm or your EOC, most often answer choices are going to be reduced. So you need to be able to do that just because otherwise if you don't see 4/6 as an answer choice, you need to be able to recognize that 2/3 is the same as 4/6. Jesse, is that what you're going to ask? Like, do you have to do it on a test? No, I was asking like you could do it on. Oh, could you do it up here? Absolutely, yeah. Like how many of you guys have, you would say like this is 1, this is 2. Yeah, you can do it up there. That usually makes it smaller numbers, so that might be easier for you. I don't really care. Again, doesn't matter to me, whatever your process is. Okay. How about this one? What's happening here? What is this thing on the left? A mixed number. It's a mixed number right now. What do we need it to be able to work with it? Improper fraction? How do I go from here to there? All right, so 2 times 3 is, plus 2 is, okay, again, the t's on the right side, but what do we still want to get rid of? Negative 3 over 5. So how do I get rid of a negative 3 over 5? 5 over 3, not positive, negative. You need to use a negative because a negative and a negative, that's what cancels out. So over here, I'm going to multiply by negative 5 over 3 because I ultimately, David, want this to end up being what kind of t? Positive or negative? Positive. So a negative times a negative gives me a positive. That's why you have to do negative. All right. So if I multiply by negative 5/3 here, what do I do here? All right. What happens over here? 5 and the 5 go away. The 3 and the 3 go away. What am I left with on this side? Just t. And then what do I do here? 5 times 8, which is 3 times 3, which is positive or negative? Negative, because one of mine is negative. And I'm done. There's nothing I can reduce there. You can make it a mixed number if you want. You can make it a decimal if you want. You can do whatever you want. I am going to leave it like this. All right, negative 40 over 9. So the only wrench, the only thing that changed when you had a mixed number was what was your first step? Making it an improper fraction. And we do that because otherwise, how do you find the reciprocal of something? You can't do that unless it's in like just standard fraction form. Okay, so let me check your, yes, okay. So for your practice, I would like you guys to do the odds. 1, 3, 5, 7, 9. So all the ones on the left, just the left side, 1, 3, 5, 7, 9.